passed surrounding the tubes, and in the other type of boiler is 5 tube boiler. That means, the flue gases will be passing through the tubes and water will be surrounded by the tubes. This is the basic difference between the two types of boilers, that is water tube boiler and 5 tube boiler, but more economical is 5 tube water tube boiler only, because passing the water in through the tube and passing the flue gases surrounding the tubes, it is very economical and the life of the boiler tubes will increase. So, therefore, mostly the thermal power station they go for Babcock Wilcox water tube boiler. Next one is superheater. The purpose of superheater is to convert waste steam into high steam. The superheater also it consists of larger number of tubes and the wet steam is passed through the superheater, and by taking the temperature from the flue gases, the wet steam is converted into the hot steam, and basically the tubes which are mounted in superheater, they are made of chromium and molybdenum to avoid the rust. Then economizer. The purpose of economizer is when the water is coming from the condenser, it will be passed to the economizer, where the economizer will convert this wet water into hot water by taking the some of the temperature from the flue gases. This hot water is fed to the boiler, so that the boiler efficiency increases. So, the purpose of economizer is to convert the cold water into hot water or to reheat the water, which is again feeding back to the boiler. The next part is air preheater. Air preheater is to convert the cold air into hot air, and this hot air is fed to the boiler. Economizer and air preheater. And some more points. Condenser. The purpose of condenser is to convert the steam into condensate form. In these two types of condensers will be there, surface condenser and jet condenser. Basically, surface condenser will be used in power stations. Then cooling tower, the purpose of cooling tower is to convert the hot water into cold water. This cold water is fed to the condenser. Then turbine, which is the main unit in the power station, which converts the steam energy into mechanical energy. Then alternator, which converts the mechanical energy into electrical energy. Transformer, basically in power stations, the transformers are distribution type of transformer and step down transformer and step up transformer will be used, and the electrical energy will be generated 11 kV or 13.2 kV by using the step up transformer. This 13.2 kV is stepped up into 400 kV, 660 kV, 220 kV according to the need of the customers. Then bus bar. Bus bar is nothing but a distribution box or junction box, where from there it will be connected to different switch yards. Let us see what are the advantages of a thermal power station. The advantages of thermal power stations are: 1. Large amount of power can be generated, fuel used is quite cheap, less initial cost, installed at any place, requires less space compared to hydropower stations, These are the few advantages compared to any other thermal power station. And when there is an advantage, always power station will also have a disadvantage. Can you imagine what is the basic disadvantage of a thermal power station? Lot of pollution will be there. The pollution is due to the ash, the pollution is due to the flue gases, and therefore, due to this pollution, this thermal power station should be located far away places from the thickly populated areas. Let us see the disadvantages. pollutes the atmosphere and ground due to smoke and fumes, etc. This is the main disadvantage of thermal power stations. The number 2 is running cost is more than hydroelectric power station. Because of various apparatus, the running cost of thermal power stations will be more. Let us see, we have seen the advantage and disadvantage. Let us see some of the points how to select the thermal power stations, where to select. For each factory, or suppose we want to set up any industry, we have to see some points before selecting the power station or industry. Let us see one by one what are the points we have to see before setting up a thermal power stations. Selection of site for thermal power station. The thermal power station should be nearest to the coal mines. It should be nearest to the coal mines, so that the transportation will be avoided. Availability of water. We have seen in the diagram, the condenser needs more water, therefore, it should be nearer to the water point, either lake or tanks, etc. Transportation facilities. The transportation facilities should exist. Cost and type of land. The cost should be very cheap, and at the same time it should not be any loosey soil, it should have a hard soil, so that it should not be the equipment should be mounted very easily. So, cost and type of land. Nearness to load centers. Always the thermal power station should be located as far as possible nearness to load centers, otherwise the transmission system cost increases, and if you are considering for the DC power stations, we cannot step up or step down the voltage. Therefore, it should be nearer to the load centers. Distance from populated area. Due to the pollution, it should be located away from the populated area. Labor should be available. The plenty of labor should be available to run the thermal power stations. So, we have seen the selection of site for thermal power station. Let us see what is the efficiency of thermal power stations. So, after taking so much care in thermal power station, that is, we are not wasting the water, we are not wasting the flue gases, we are not wasting the steam. Even then, the good thermal power station or the modern thermal power station, they gives only 30% of the efficiency, balance 70% will be losses only. In this, 50% of the losses occurs only in condenser, balance power losses will be occurring in a superheater or through the tubes, they will be escaped into the atmosphere, economizer, etc. So, the thermal power station efficiency will be not less more than 30%. Efficiency of thermal power stations. Overall efficiency is 29% to 30%. Huge heat loss in the condenser, heat loss into the atmosphere, superheater, turbine, boiler, etc.